What is up guys, it's Mustafa Khan, and in this video I'm going to attempt to take over the sky and turn it into whatever I want using the beautiful help of some machine learning. So why am I doing this? It's a good question. I believe at some point we'll move beyond the impressive but still rudimentary augmented reality technology that we have nowadays. And we'll be in a world where our daily perception of reality is not just augmented, but can literally be controlled by us. So if you're walking down a street and don't want to see a billboard, you can remove that from your vision. If you want to stand still, but still see around you in 3D space. And if you don't want to experience nature in the same way as before, then there's no reason why things like the sky can't just be changed into something that you want it to be. And the impressive thing is that a lot of what I just described can actually be done today, maybe just not in a unified manner. So that's exactly what I wanted to explore today. We'll target changing the sky, and we'll do this by going through a paper called Castle in the Sky, Dynamic Sky Replacement and Harmonization in Videos. Quick side note before we get into this paper, I think getting to the root of a field of knowledge is best done by reading the research papers in that field. It's the quickest way to learn, which is why my videos in this format always go to papers and their findings first. It also allows you to gather a wealth of insight from the work that other people have done, which can be extremely beneficial when eventually you want to create something new yourself. So back to the paper. There are 3 key ideas that you need to understand from this paper. A sky matting network is used to detect sky regions in video frames. Unlike other approaches, which turn the problem into a pixel-wise classification problem, meaning we're trying to determine if a pixel is part of the sky or part of the foreground, this paper approaches the problem using an encoder-decoder network. The encoder aims to learn features of the input image, while the decoder is trained to predict a coarse sky mat. So what's the result of this part of the process? Well, a sky mat is produced, which can now be used downstream to replace the sky in the video. Next, a motion estimator recovers the motion of the sky. Each object in the sky, such as a sun or clouds, is considered to be at infinity, and their movement relative to the foreground is assumed to be affine, or parallel to the ground. This motion is estimated by computing the optical flow of these in-sky objects, which just means tracking the apparent motion of individual pixels in the image. This motion is then rendered in the final part of this pipeline, the SKYBOX. A 360-degree SKYBOX template, which is usually used in creating the skies of video games, is made. Given the foreground frame, a predicted sky mat, and the motion parameters, the SKYBOX aims to wrap the sky background based on the observed motion and blend it with the foreground. The SKYBOX also applies relighting and recoloring to make the blending result more visually realistic in its color and dynamic range. How about we test this in action now? Now we're gonna go outside and use the machine learning model to make the SkyAR. This world's technology is advancing at an insanely rapid pace. I get to see that firsthand because of what I study and work with on a day-to-day basis. If you aren't conscious about the manner in which that development is happening, then we might be consumed by the advances that we make. On the other hand, if we can understand those advances, then we can leverage that to redefine ourselves or keep evolving. So we learned about sky replacing technology, used that to control the sky, and got a glimpse into what altering reality would potentially look like in the future. Make sure to hit that like and subscribe button if you enjoyed this video. Drop a comment telling me what you would do with this technology yourselves, and share this with a friend. That's about it. See you in the next one.
Bye.